this experiment, we'll be showing how to accurately measure the mass of an object using a tri-state balance or analytical balance. Before we begin, let's examine what uncertainty actually is. Uncertainty is an amount of imprecision or unprecision that a device will automatically have if any value it records is beyond that of a whole number. There are two types of error here, and that is systematic and random. In this specific example, systematic errors are prevalent because those are errors that are present within the machine's calculations or erroneous observations by participants in the example, or the experiment rather. The last number on the analytical balance, which is probably to the thousands or 10,000s place, will shift. That is because air particles inside the machine will be moving, or external forces will affect the balance.
Alright, we're going to get the mass to the beaker. As you can see, the mass is 69.136 grams. Just writing it over there. Now we're going to take the beaker out and put water in it. The volume of the water is at 4.5. And put it into the beaker as such. And now we're gonna weigh the beaker with the water. Got to re-zero it to make sure that we do that. And the new mass is 76.932. Now, we're going to subtract to find out the mass of the water.
According to my calculations, the mass of the water should be 13.804 grams.
Okay, what we're going to do is we're going to take the beaker, we're going to zero the balance, we're going to set the beaker inside on the balance and get the mass of it. The beaker weighs 69.499 grams. And he's writing that down on the notebook. While he's doing that, I'll take the beaker out and we'll add an amount of water to the beaker. And that amount of water that I'm adding is 4.0 milliliters of H2O liquid. And to hurry the process up, I will squeeze the water out with the bulb. And now we will put the beaker with the water back on the balance and shut the door. And the new weight is 76.766 grams.
mass of the water appears to be 7.318 grams.
And now I'll take out the beaker with the water in it and I'll tare the balance to get it back to zero.
First, we should accurately measure the mass of the beaker. Zero the machine. The readout appears to be 69.80 or 80. Once that has been completed, we shall use a more pipette to transfer a desired amount of water to the beaker. The mass of the water appears to be 5.1 milliliters. Excuse me, the volume. Should not transfer the liquid into the beaker. I'm going to make sure we get everything up. Alright. Now that that task is taken care of, we shall re-zero the machine. Place the beaker on the balance. The new mass reads as 75.819 grams.
Minus 69.480 grams. And the weight of the water that we put in the beaker is 6.339 grams.
In this video, the laboratory experiment was conducted by Jevon Coleman,
R.J. Jackson.
And Logan Harbin.
Thank you for viewing this video. I truly wish that it was extremely helpful to you.